In a supervised classification, you choose the areas that are to be used for training for the analysis. Training areas should be a homogeneous sample of a particular feature, such as the forested areas in the image that we used in Task 1. For each training area, the multispectral pixel values are extracted and used to define a statistical signature. The signature is a statistical representation of a particular class, which is used by the software to identify all pixels within a similar signature. First, open MultiSpec. If you're a Windows user, it will be located in Lab 6 Data, MultiSpec, MultiSpec Win32, and MultiSpec W32.exe. If you're a Macintosh user, it's again in the MultiSpec folder under MultiSpec Mac OS X, MultiSpec 2.8.16F, and then the MultiSpec app. From the File bar menu inside MultiSpec, click File, Open Image, go to the Lab 6 Data folder, and open the AG020522_DPAC image file. The Set Display Specification for window opens. Take all the defaults and click OK. From the menu bar, click File, New Project. The project window will open. Click OK. Now we'll begin to select training areas. Again, these will be homogeneous areas. Start with the forested area. Simply drag a new box within the forested portion of the image. So that's going to be over here. Note that when I do that and let go, you'll see that we have the coordinates over here in the project box. When I click Add to List, it's going to ask me for a class name and a field identifier. Enter the class name of trees and the field identifier of field 1. I'm going to make sure training field is selected, and I'll click OK. We will then define 5 additional training areas, one for wheat, soil, light soil, no data, and weeds. And so let's do that now. So once again, I'm going to, over here on the wheat, click and drag a box, click Add to List. I'm going to call this in wheat, and click OK. Then we're going to do soil, Add to List, soil, okay. And then light soil, add to list, light soil, okay. Then we have no data. And then finally, we have weeds. Okay, so in the project window, click the Classes button so that we can see all of the classes that we have created. If necessary, you can delete a class by selecting the class in the list and selecting Cut Class from the Edit menu. So that'd be up here, Cut Class. From the menu bar, choose Processor, Classify. There we go. To open the Set Classification Specifications dialog box, uncheck Image Selection. The other default settings are fine, so click OK. If prompted to update the statistics before continuing, click OK. So since the image selection was unchecked, MultiSpec only estimated the quality of the training areas. You can examine the tabular output to assess if the full analysis should be run. So here, if we look at the text output window, the training class performance table tabulates how the pixels of each field and class were classified. The reference accuracy, so here, should be near 100% for all training fields. Assuming satisfactory results, we're ready to classify the entire area. So from the menu bar, we're going to choose Processor, Classify, to open the Set Classification Specifications dialog window. Set the classification specifications as follows. So uncheck Training Resubstitution. Check Image Selection. Check Disk File under Write Classification Results so that a disk file of the analysis will be created. Check Create Probability Results File. And then click OK. The analysis will run, and shortly you are prompted to save the two resulting files. Take the defaults and click OK both times. So notice we are saving in our Lab 6 data folder. So I'm going to click Save. And then for the second one, we're going to once again click Save. For the menu, choose File, Save Project As, and in our Lab 6 folder, we're going to save this as lab6.prj, which is the project file format for MultiSpec. To see the results, choose File, Open Image, and set the files of type thematic. Inside the data folder, we are now going to choose the AG020522_DPAC.GIS file. So I'm going to click Open. The Set Thematic Display Specifications window opens. Click OK to take the defaults. The results look much more realistic than those obtained from the unsupervised classification. To see the training area superimposed on top of the results, go to the menu bar and choose Project, Add as Associated Image. To change the training field outline color, go to the menu bar and choose Processor, Statistics. The Set Project Options window opens. Under Outline, Selected Areas, choose Color, Black. I'm going to click OK. There we go. And so to visually evaluate the results, you can move your cursor over a color patch in the table of contents for one of the classes. Hold the Shift key down and your cursor will change to an open eye, and click the left mouse button to cause the colors on the map for that to flash on and off. So here I'm holding down the Shift button, and if I click and hold, you'll see that those colors will flash on and off. You can also change the colors of the classes by double-clicking on the color patch in the table of contents and choosing a different color. So, for instance, let's see here, for trees, let's make that a nice green color. I'm going to make it this green here so it's easy to see. There we go. So, look at the text output once again. Under the class distribution for selected area table, you'll see the number of pixels and the percent of the image that ended up in each class. Now we will bring the multi-spec supervised classification results into QGIS Desktop. If necessary, open QGIS Desktop. Okay, now we are going to click the Add Raster button, and we're going to choose the DPAC GIS file. Make sure that your filter is set to all files once again. I'm going to click OK. And now right-click on the layer in the Layers panel and choose Set Project CRS from Layer. Alright, so now double-click to open the layer properties for this layer and go to the Style tab. Choose the following rendering options. The first will be single band pseudo color. We're going to choose random for the color ramp, so random colors down here at the bottom. We're going to choose equal interval as the mode, which we have there. We're going to set the number of classes to 6, and we're going to click the Classify button. So change the values of 1 to 6 to match the class values in the data. So for instance, number 1 was trees. Number 2 was wheat. Number 3 was soil. Number 4 was light soil. Number 5 was no data. And number 6 was weeds. There we go. Okay. So we can also click on the individual color patches and change them to more intuitive colors. So once again, for the trees, those are pretty decent green, so I'm going to leave them there. For the wheat, I'm going to double click and I'm going to give it, let's go over here. I'm going to give it kind of a yellow color, so maybe go with that, maybe up the yellow some. For the soil, let's go with a kind of brown color, so maybe something like that, maybe a little browner. For the light soil, let's do the same, maybe lighten it up some. And let's see here, for no data, what I want to do here is, let's see here, go ahead and just make that fully transparent. And for weeds, let's make that red. Okay. And so now I'll click OK. And here you can see our resulting symbolized image.